All right, so we are going to be learning how to rewrite equations and formulas. You wrote your definition of a literal equation. Somebody tell me, what is a literal equation? Right, the equation, and they give you an example. In this case, they used ax plus b equals c. So it's any equation written in this form, and it can be rearranged, they replace numbers with letters. It's showing you so you can memorize the formula for later, essentially. And the nice thing about all formulas and equations is you can rearrange them to solve for any variable. You can solve, like in this case, we could solve for x, we could solve for b, it doesn't matter. So we're going to practice this. Go to example 1. We have ax plus b equals c, and they would like us to solve for x. Okay, so what's my first step?
Subtract b.
Yep, subtract the b. So then I'm left with ax equals c minus b. Now how do I solve for x?
Divide by a.
Divide by a. Divide everything on the other side by a, so you're left with x equals c minus b divided by a. All right, I'm going to write this on this next page. X equals c minus b divided by a. So now they give you 2x plus 5 equals 11, and they want you to use this equation to solve for x. The way you use that is you look at what numbers are where and which letters these represent. What does the 2 represent? This is A. What does the 5 represent?
B.
And the 11? So we just plug in those numbers. So we can say x equals, C is 11, minus 5, which is, because this standard formula is ax plus b equals c.
That's the standard formula.
Yep, I would memorize that formula.
I should write it though.
Yep, make sure you wrote it. Ax plus b equals c. This is the standard form of, you remember the linear equation, y equals mx plus b?
Yeah.
This is the standard form of that.
Wait, what happened to the A?
Happened to the what?
To the x equals 11?
I haven't. The x equals,
11 minus
I haven't finished, because Ben asked me a question. So we have 11 minus 5, which is c minus b, and then what's a? 2. So now we just solve this. What is 11 minus 5?
6.
And what's 6 divided by 2? So x equals 3. Any questions? So you can always rearrange an equation as long as it's not, as long as it doesn't have an exponent, to the standard form. And when it's in the standard form, you can use it to solve for a variety of things. So let's do another one to practice real quick. You can choose whether or not you want to put this in the journal. So we have a minus bx equals c. This one's a little bit different. We're going to solve this for x, and then we're going to use 12 minus 5x equals negative 3. So you see that these are already here. This is A, this is B, and this is C.
Yeah.
But for the beginning, let's solve the original equation. So to get x by itself, I'm going to subtract the A. So I have negative bx equals c minus A. Now how do I get the x by itself?
Divide by negative b.
Divide by negative b. Divide by negative b. So I get x equals, now the only catch here is when you have a negative divided by a negative, what does that make it?
The whole thing negative.
Yeah, these change the sign in the middle to positive, but you have to put a negative in front of the c.
So negative c plus a.
So you could say negative c plus a divided by b, or you could say
Just do the
a
original.
minus c divided by b.
Could you do the original? Or no?
You could leave it as c minus a over negative b, But then you have to remember when you plug stuff in that the signs might make a difference. So I would go ahead and simplify it before you plug it in. I think it's easier. So once you have your equation, I'm going to use this one. And all I did was flip the a and the c on the same side, so it's a minus c. That just makes the mental math easier is all. So a is 12 minus, what's c? Negative 3, divided by b, which is negative 5. Well, we have a negative next to a negative, so that makes that a positive. What's 12 plus 3? And then we're dividing by negative 5. 15 divided by negative 5 would be negative 3.
Was that negative 15 or positive?
That's a positive. That's the equal sign. It's kind of spread out there.
Is that a negative 5 at the bottom?
It is a negative 5 on the bottom.
And why is it a negative 5 on top?
That's not.
That's an equals.
This is an equals.
Wait, but like why isn't it? Because I thought whatever you do the column.
Right, but then I'm subtracting by a negative 3, which makes it a positive. A negative times a negative is a positive. That's why I always throw those parentheses on there. Good questions, guys. There, we got that? Let's do one more. These just take a little bit of practice, guys. You'll get it. So guided practice number 2, we have ax, equals bx plus c. And then the equation is 11x equals 6x plus 20. So I'm going to go ahead and label these. This is A, this is B, and this is C. So again, we're going to solve for x. This one will be a little bit trickier.
We have to combine our differentials.
Right, but
So we a plus b.
Minus c. Wait, minus bx?
let's move the bx. So you get ax minus bx equals c. Now, how can we get the x away from both of those?
You can divide it?
No, this one's a little trickier. You can reverse distribute. So you can take a minus b and put the x on the outside. Because remember, if I were to distribute this, I'd have a times x and b times x. So if I pull it out, I call it reverse distribute. I don't know if that's actually a thing. But it's what you're doing. You're taking the distribute, and you take it back out. Yeah, and then equals c. So then this becomes easy because you just divide a minus b away. So you get x equals c over a minus b. Does that make sense? So yeah, when you're looking at something and you see that they both have the same letter, you can always pull the letter out and then leave what you saw. You can do it with numbers too. Like if you saw...
This is the same thing, right? Because ax and negative.
Yeah, you just think reverse distribute. Say you saw 2x plus 2y. I could write that as 2x plus y. And then I can solve, yeah. So that's just an example. So you can do it with numbers or variables. It doesn't really matter. All right, so now let's plug in our actual numbers. So I have x equals c is 20 divided by 11 minus 6. What is 11 minus 6? What is 20 divided by 5? So x equals 4. All right, we've done a few tricky ones. You feel better? Have a good understanding? All right, so now that you understand how to do one variable, we're going to add another variable. So example 2. We have 3x plus 2y equals 8. This is what starts getting you into a linear equation. You can solve this for y and it's in a linear equation. This is your standard form. So we're going to solve this so that y is a function of x. Starting getting into functions. When you hear that y is a function of x, you're basically solving so that y is by itself and it equals everything else. Okay?
So try and get y by itself.
Try and get y by itself. So the first thing I want to do is
Minus 3x.
subtract the 3x to move it to the other side. So I'm left with 2y equals, and I always put the variable first, so I'm going to say negative 3x plus 8. Very good. And then how to get the y by itself? You divide everything by 2. So I get y equals, and just leave this, negative 3 over 2x plus, what's 8 divided by 2?
Negative 3x.
3 over 2x. Because you divide that 2 to both sides. See? You divide it here and here. But you can simplify this side because it's an even. So we simplify that into the 4, and we leave the slope as negative 3 over 2. So this is considered your answer. And that's slope-intercept form. Once you have it in that form, you could graph it. Good?
Yeah.
All right, let's look at 3. This one, we're going to use a geometric formula. A equals 1/2 BH. Somebody tell me what that is. What formula is that talking about?
It's on the triangle.
Yes. What are we looking for? What does A stand for?
The
Area. So this is the formula for area of a triangle. Very good. And yep, base times height. B. We're going to solve in this case for h. Okay. The trickiest part of this is the fact it's got a fraction. When you have a fraction, normally you would divide 1/2 out of here, right? Because it's multiplying 1/2 times b times h. But since it's a fraction, you can't divide it. You're actually going to multiply times its reciprocal.
Oh, that's, yeah.
So multiply times that reciprocal, you get 2a equals b times h. Now how do I get the h by itself? Divide by b. So h equals 2a over b.
H equals 2 over b. H.
Okay, they gave you a little triangle and told you that the base was 14 and the height we don't know, and then they told you that the area equals 64.4. So now can we solve for h? Yeah. We can plug in and we can say h equals 2 times area, which is 64.4, all divided by the base, which is 14. So if you did 2 times 64.4 and then divided that by 14, you should get 9.2. Now, we have to say 9.2 what?
Meters.
Because this is a word problem. So we know the height of that triangle is 9.2 meters. Any questions on how I did that?
No.
Do you feel comfortable rearranging the equation for any variable, or do you want me to do another one?
Another one.
Another one? Okay. So this is number 3 on your guided practice. We have 5x plus 4y equals 20, and we need to solve for y. So what's my first step?
Minus 5x.
Minus 5x. So I get 4y equals negative 5x plus 20. What's my next step? Trying to get the y by itself. We've almost got. Yep. Get the 4 away from the y. So you get y equals, and then I simplify. I can't simplify negative 5 over 4, so I just leave that. And then I can simplify 20 divided by 4, which is 5. Does that make sense?
Can you do one of the earlier problems?
Where you're solving for weird variables?
Yeah.
Sure. So if I have ax equals bx minus c, and then we know that it's 8x, 3x minus 10. So in this case, we know that this is a, this is b, this is c. So the first thing we're going to do is solve for x over here on the left. This is almost identical to one we did, isn't it?
Yeah.
That's okay. It's good practice. So I'm going to move the bx to this side. So it's canceled here. I get ax minus bx equals negative c. Now how do I get the x by itself?
Reverse distribute.
I know it's funny, but it works. Reverse distribute. So I'm going to pull the x out and say a minus b equals negative c. Now how do I move the a minus b? Yep, because remember the parenthesis means multiply. So to move it, I just divide it. So then that's canceled. I'm left with x negative c over a minus b. Now, you see how you can leave it like this, but you see how there's a negative on the top and bottom? We can actually simplify this. So it would change these two signs to positive, and it would make that negative. Bless you. And if this hurts, then leave it. That's fine. Having a negative up there is not the end of the world. But because there's a negative on the bottom, you can say that, and you would change this to c over, and then I would just switch it b minus a. But it's not wrong to leave it this first way. Okay? Now, once you have that, we can plug stuff in. So c equals what?
Negative.
Divided by what's b?
3x.
Which is 3. And then a is 8. So we have, what's 3 minus 8?
Negative 5.
So a negative divided by a negative makes it positive, and 10 divided by 5 is 2. So your answer should be 2. You want to do one more of those tricky ones?
Yes.
All right, here's a really good tricky one. And then the numbers is... All right, so let's label this. This is A, this is B, and this is C. All right, so over here on the left, we need to solve for x.
Divide by...
You could, but you could divide by A, because this means multiply, right?
Get that.
So if we divide by A, that cancels. I'm left with x plus B equals C divided by A. Now how do I move the B?
You subtract it.
Very good. So I get x equals C over A minus B.
Then you would... let's see.
Now I plug stuff in. What's C?
C is 9.
Over 2 minus 1. What's 9 divided by 2?
9 to
4.5 minus 1.
3.5.
3.5 is my answer. Very good. I think this is the one in algebra was always my favorite subject. This was the hardest concept for me to remember to do, was to, instead of automatically distributing, I don't need to distribute, I can just move it instead. So don't be afraid to rethink the first step sometimes. Good? All right, last one, example 4. Of course we have to deal with a Fahrenheit Celsius formula once. So you are visiting Toronto, Canada over the weekend. A website gives the forecast shown. Let me take a picture. And find the low temperatures for Saturday and Sunday in degrees Fahrenheit. Use the formula C equals 5/9 times F minus 32. This is the actual formula for Celsius, guys. C equals stands for Celsius and F stands for Fahrenheit. So, what is the temperatures we're trying to look at for the lows?
14 and 10.
Saturday and Sunday? You don't care about Friday? I circled, there we go. Okay, so this is what we're looking at. So we have Celsius and we're trying to solve for Fahrenheit. So maybe we should rearrange this equation so that Fahrenheit's on the outside first. So, what's my first step to get Fahrenheit by itself? I'm going to try and push your brains here. What do you think? This means what?
Divided by 5/9.
Good. And since it's a fraction, you're actually going to flip it and multiply.
Okay.
So I have 9/5 Celsius equals F minus 32. What's my next step?
Add 32.
Yep. So I get 9/5 Celsius plus 32, and all of that equals Fahrenheit, which I'm going to move over to the other side now. Oh wait, I have room. All right, so now to solve, I need to plug in my 14 where?
Where the C is.
Where the C is. So for the first one, I'm going to say F equals 9/5 times 14 plus 32. So if you grab your calculator and do 9/5 times 14, you get 25.2, and you add 32 to that, you get 57.2 degrees.
Fahrenheit.
Yeah. And this is what day? Saturday. So now we need to do Sunday, which we have F equals 9/5 times 10 plus 32. So if you do 9/5 times 10, you get 18 plus 32 gets you 50. So my answer is 50 degrees Fahrenheit, and this is on Sunday. So there's your two answers. Both those days seem a little chilly, but you are in Canada, so. All right, any questions about rearranging equations? It's essentially your lesson. Rearrange your equations and then sometimes solve for the actual number. So you're doing numbers 3 through 8, 11 through 22, and then 24 to 26. Sorry, it's all broken up, but it's the problems I want you to do.